Guys and girls, it's know it time!
Alright guys, brand new day, brand new topic. So today, your lesson is going to be on dividing radicals. Dividing radicals really is all about multiplication. Okay, that's what it's really about. It's about multiplication. So this is our topic for today, dividing radicals. Guys and gals, it's know it time. Your favorite time of the day. 1, 2, 3. Here is how it works. Let's say I have square root. Yeah, you do. Every week you get only 2 lines per week, so every Monday I add 2 more.
Yeah, we already have that.
I know, you gotta wait till next Monday.
Next Monday?
Oh, you gotta wait for a long time for next Monday. Oh, because every week you get 2 lines only.
But what if it's like every second week? Because this is like double blocks.
Oh, good point, good point.
So
But write on a sheet of paper. What you just said, and put in my blue suggestion box. One day kids are gonna buy me like a blue suggestion box. Yes, guys, gals. When you have 2 square roots like this, now some of you must know I'm too lazy. I don't want to simplify the top. I don't want to simplify the bottom. What you can do is you can merge them together. This is a property. So one big gigantic square root sign. This is called properties of. See, this is too. Some of you say, I'm too lazy of doing this. So you can rewrite this as 16 over 2. Now 16 over 2 can be broken down into 8. But we're not done yet either. Guys, gals, finish it for me. Crystal, what is it going to be? I'll give you a hint. It has a 2 in it. 2 root 2. Now, in case if you're lost, I'm going to show you where that came from. From my previous lesson, I told you that you got to use these magic numbers I gave you. 4, 2. And root 4 is really 2 root 2. Now, before you go about and do this left and right, I'm going to give you a few little minor hints here and there. Okay? Star. Only merge your radicals if you can reduce it after. Otherwise, it's pointless merging them after. I'm going to give you an example of a question. Okay? Only merge your radicals if you can reduce it after. If I have a question like this, root 9 over root 5. Right off the bat, I know some of you will say, hey, mister, let's just merge them together. Look what happens when I merge them together. It gets 9 over 5. See, this is messy. I can't do anything to it. So this is an example of do not merge. See? In this case, do not merge. See, merging is only used if you can reduce it after into something nicer. In this case, guys and gals, I just leave it the way it is. This would be root 9 over 5, root 5. Nope, you can't merge it, because when you merge it together, you get 9 over 5. A 9 over 5 really can be broken down into something nice. Ah, you can simplify. Simplify the top for me. Serena, root 9 becomes 3 over root 5. I can't do anything to this. So a lot of you will circle this and say, hey, Miss Snow, we're done. But back in grade 10, your grade 10 teacher probably slap you if you did this. Why or did he or she slap you leave like this? Harmeet, why? Why is this not correct?
Because you can multiply 2, the top,
Yep.
and go to the bottom, then you send 5.
On the right track, but wishy-washy, not to. See, the key is this, so I'm going to write down a few more notes for you, because really, you need some notes. Star. Okay. In life, the denominator should not be a radical. Denominator should not be a radical. Because it's not standardized. Mathematicians hate that stuff. Should not be a radical. So mathematicians came up with a way on how to get rid of the radicals in the bottom. I'm going to show you the 2 techniques of doing this. 2 ways to get rid of to get rid of the radical in the denominator. Does anyone know where Risham is, by any chance? Anyone going? Nope. In the denominator. There are 2 ways. I'm going to show you the first method. Technique number 1. This is called rationalizing the denominator. So you have 3 root 5. To rationalize the denominator, we're going to multiply this by another fraction. I'm going to pause it right here. I want to see if you remember back in grade 10, what your grade 10 teacher taught you and how to rationalize it. I walked around, and there were only 2 people who got this correct. So to rationalize the denominator, here's what we're going to do. We're going to multiply by another fraction, and the other fraction is the denominator. So my denominator here is root 5, so we're going to multiply this by root 5. And on top will be root 5 also. Because root 5 over root 5 is just 1. So guys, gals, go ahead and multiply.
Why do you multiply by 1 instead of saying?
Because if you multiply by 1, the denominator is still there. Oh, tricky. So if you go ahead and multiply this out, if you multiply this out, the top part, Hartaj, what would you get on the numerator? Oh, sorry? 15? No. Amar, what did you get? 3 root 5. Remember, when you work with division, it's pure multiplication. You have to know your multiplication stuff. Now, Jason, you weren't here, but let's just test your skills out. Root 5 times root 5?
5 root 2.
Whoa. What's the square root of 25? 5. There's no 5 root 2. Very nice. So guys, or here's another way. Remember what I said? When you multiply a root times a root and it's the exact same thing, the square root say bye-bye. So guys, this is your final answer. And this is how you leave it. See? The square root on the bottom is gone. And you're just left with that. Try this. I want you to fix this. This is bad. Make bad into good. 5 root 2 over root 4. So, no, not root 4. Sorry. Root 6. You know I can't do like this. If you merge it together, it still doesn't look nice because you still have a fraction. Guys, gals, I want you to go ahead and simplify this. I'm going to pause it. I'm going to show you what not to do. If you merge these and say, hey, mister, look, I'm going to try to merge them together. If you merge it together, you get 2, 6. Some of you will try to merge. That's still a fraction. It doesn't work out nicely. So merging them doesn't work. So if merging doesn't work, let's just rationalize it. Yuvraj, what am I going to multiply this by, Yuvraj? Root 6 over root 6. Guys, gals, go ahead and work this out. The bottom, I'm going to tell you, is going to be 6 for sure. The top, Who haven't asked today? Ruby, what's on top? 10 root 3. Let's do this slowly first. 5 root 12. But 5 root 12, Ruby says, Mr. No, that's not correct yet because you can simplify this even further. And this becomes 10 root 3 over 6. But we're not done yet. Why isn't it done yet, Harsh? Sammy, why isn't it done? Sorry? You can reduce it even further. Guys, I'm going to pause it right here. Remember, 10 and 6 are the outside numbers, or my coefficient. I can reduce this by 2. So this becomes 5. This is 3. Your true final answer is 5 root 3 over 3. Now some of you say, Mr. No, can I cross out that 3 and root 3? The answer is no. Guys, gals, now that's as low as you can go. Easy? It just takes a bit of practice. I'm going to give you one more before I make it a bit more challenging for you. What if I do this? 2 root 12 over 4 root 3. I'm not going to help you out. Many of you will have different methods of doing this, but I'm going to pause it just to give you a little tiny hint. I'm going to multiply. Oh, no, you don't have to multiply this. 1. The answer is indeed 1. Some of you try to multiply this by the rationalize the denominator. Guys, gals, when you rationalize the denominator, notice I'm just going root 3, not 4 root 3, because I'm only using the square root part. But there's an easier way. I can merge my two square roots together. Oh, look at this. Look what happens when you merge the two square roots together. You get 2 over 4 times root 4. See? I merge them together. So this becomes 2 over 4 times 2, which becomes 1. Wait. Can you? Simplify and divide? Yeah, you could. Up to you. Many ways of doing this. There's no right answer. Okay, there's many ways of approaching this problem. One more. And I'm just choosing a nasty one. Actually, I think you should be ready for this one. Next one, that's method 1. Method 1, rationalize the denominator. Method 2. Method 2 is called multiply the conjugate. Some of you probably not have heard this word before. I'm going to highlight the word conjugate. To understand what a conjugate is, I'm going to go over some stuff with you. Let's try 1 minus x. Times 1 plus x. Now, a conjugate really is two pairs. Okay, here are my two pairs of brackets. Now, look at the first thing that you notice. 1 is a minus. 1 is a plus. That's the first difference. So a conjugate means they're opposites of each other, or it really means this is called the difference Actually, no. I'll teach you about that later. But for now, guys, gals, I want you to multiply this out. Take a minute, multiply this out. I'm going to pause. If I were to multiply this out, you have 1 plus x minus x minus x squared. So really it becomes 1 minus x squared, which is correct. I want you to focus on the pattern, because I want you to go from here to here in one shot now when you multiply it by the conjugate. Focus on how the pattern works. The middle numbers just disappears. What if I have this? 4 minus y, 4 plus y. Look at this. It's a conjugate again, because the pairs are identical to each other. Okay, and notice nothing. This is a minus, this is plus. This is what we call conjugates. Doing one shot without even expanding this out. Pavan, what is it going to be? 16 minus y squared is correct. And if you don't believe me, go ahead and multiply it out. A bit more challenging this time. Let's use square roots. 3 minus root 2. What is the conjugate of 3 minus root 2? No, actually Manraj. What's the conjugate of 3 minus root 2? 3 plus root 2. Guys, gals, I want you to expand and solve. Try to do this in one shot. Let's see who can do this in one shot. 7? That's the speed and level you have to work at. Some of you say, Mr. I didn't even pick up my pencil yet. How did they do it so fast? Okay. So remember, conjugate really is a pattern system. Look at how these numbers arrive. I squared the first number. That's where 16 came from. So let's go 9. The second sign will always be a minus. No exceptions to this rule whatsoever. Always be a minus. Now, to get the last one, all you have to do is square this piece, whatever this is. Y squared, so I square root 2. The square of square root of 2 really is 2. 9, and this is why some people say, Miss Snow, the answer is 7. Guys and gals, you're ready. Good luck with this one. You're not ready yet. Soon you will be ready for Super No. 2 minus root 3. If I look at this, right off the bat, you know it's a conjugate question. How do you know? Because look, I don't have a lonely square root anymore. I have a number attached to the square root. So this technique is called multiply by the conjugate. So we're going to go times. Guys, write down the conjugate of this on the bottom, please. See, I can't simply write down root 3 anymore because there's a 2 minus there. So you go 2, we're going to use the conjugate method, plus root 3. Okay. Lavraj, what goes on top? Oh, no. 2 plus root 3. It's the same concept. When you want to get rid of the radical, we multiply by another fraction. Denominator has to be the same as the numerator. Guys and gals, I want you to work with the bottom first. Let's see how we can do this in one shot. Just by looking at it. What's the bottom going to be? 7? 7 is not correct. 1 is correct. Now, I'm going to do this aside. This really, if you multiply at the bottom, you should get 4 minus 3. Okay? And if you don't believe me, go ahead, take your time, expand this out. We're not in a rush. That's the bottom part. Now, I want you to multiply out the top part. There's really no tricks to this. Just beat it out slowly. What's the top part going to be? 10 plus 5 root 3. Okay. So we're going to just simplify slowly. So this becomes 10 plus 5 root 3 over 1. That's all you can do. Because really, this is all multiplication.
Can't you just get rid of the bottom then because it's just over?
Oh yeah, you can get rid of the bottom. Because over 1 is just 1. Good point. Guys, gals, try this one. This is your Super No question for today. Good luck. Wowzers. This is... Whew, I'm not sure if you're ready for this, but...
Wait, what's the answer? 10?
Oh, the answer is just 10 plus 5 root 3. That's it. 5? Hi. Yep. The 5 came from here. So I went 5 times 2 plus root 3. Because you're multiplying this, when you multiply this out, right? Think of this as in a nice bracket right here. Yep. So you're going to expand this out? Expand.
So it's not inside to outside.
Nope. No, sorry. Inside to outside, so 5 times 2 is 10. But when you multiply 5 with root 3, the 5 goes on the outside because there's a 1 on the outside. Okay. Guys, gals, try this one out, and I'm going to give you some questions to practice on. Good luck. I'll give you a few minutes. I'm going to walk around. I don't even have the answers to this. root 3 plus root 13 over root 3 minus root 13. Right off the bat, I can't rationalize the denominator. It's by simply multiplying by root 3 to root 3. You gotta use another technique that I've taught you. Good luck. I'm gonna pause it and let you have a crack at it. So guys, I walked around and one person got it correct. See, this question is really, would you agree that I can't do this? I can't just rationalize the denominator by going root 3 over root 3. That doesn't work. I have to use a conjugate. Hartej, what's the conjugate going to be? Yep. Good. See, I use plus. If this is the first step you did, correct. Now, let's use my little shortcut on the bottom. If you expand out the bottom, what would you get in the denominator? Would you agree this is going to be 3 minus 13? Agree? No tricks. Because if you expand this out, root 3 minus root 13 times root 3 plus root 13. Remember, when you do the conjugates, really, it's just this part squared minus, so the root 3 squared is 3, minus root 13 squared really becomes 13. Because the square root and the squared cancels out. Here comes the fun part. The top part is where what kills a lot of people. I'm going to do the top part on the bottom so everyone can see what's going on. I'm going to change this to a plus because it's a... So if you're lost, look what I'm going to do. Let's do this slowly. Harmeet, root 3 times root 3 is what? Ooh, no. 3. Because I taught you the shortcut technique, remember. You could, but the square root of 9 is 3, regardless. Okay? Oh, okay, you did that. Now, I go root 3 times root 13. Root 39. See? Again, keep it simple. I'm not going to make it too tough. Plus, now look what I'm going to do. I'm going to do this root 13. Serena, root 13 times root 3. Root 39 again. See? Root 39. Lavraj, root 13 times root 13? Nope, no calculators needed. Well, what's the trick? Remember, if you multiply 13, good. See? Again, no tricks. Because the square root of 13 times the square root of 13, it becomes 13. That little trick I taught you before. So now, would you agree the top part becomes 16 plus, here comes the fun part. Darsho. Nope, you're missing one thing. What's in front of the 39, root 39? Positive 2. Because here's the reason why. There's a 1 here and a 1 here. That's where it can kick in. So let's do this right now. I'm going to add this in. So this becomes 16 plus 2 root 39. Let's simplify right now, this bottom part, because the bottom's not simplified yet. 16 plus 2 root 39 over negative 10. Darren, I haven't asked you today yet. Darren, is this as low as I can go, or can you break it further? Break it further. Guys, gals, I'm going to give you a minute right now. I want you to break this further. If I were to break this down, I know that, hey, look, I can reduce everything down by 2. So your final answer is 8 plus root 39 over negative 5. Very nice. Is it that hard? No, not really. Okay. I'm going to pause it right here. And I'm going to assign you some work first. You're going to have after lunch to work on this. So pause. Copy this work down, and then you're going to do, I give you 20 minutes to half an hour after lunch to work on this. Page 290. Numero 6. I may have to show you 1 or 2 more things, but you should be okay. 8 9, 10, and finally 11. After lunch, we're going to work on this some more, but you can get some time first, 20 to 30 minutes just on your own, practicing this over and over again. Guys, gals, this is how we divide radicals. It's always really multiplication, and that ends our